Alright, hello. So today I'm going to give you a brief introduction of one of the machine learning project that I wrote using a GPU. So I use the cuBLAS library to do a linear regression classifier as here. So simply I use the classification for a cat image out of the other or a total of 10 types of images. All right, so the basic build of the program is quite simple. So here, the main function, the main part is basically the driver, and so it reads in the training data from this source. Actually, this is from the famous CFAR data set from the University of Toronto, and I use that as a training base for my program. So this here it loads the training data, and then it did some processing of the data, and then here is the training part. So as you can see, for their iterations, I mean during every iteration you will train the model using this function, where I will give you more introduction later, and then every 1,000 steps I will just output some information on the accuracy, the loss, and the time it takes. Yeah, so here's the training part, and then is of course the evaluation part. Here, similarly, you load in the test data, and you load it into the GPU, and then using this function, that is to predict the accuracy of the training test data using the model that is trained on the training data. Yeah, then just send the data back, and there will be a final test accuracy on the test data, and then some cleanup. So yeah, this is the main part. So I go through the core functions, where I think it will be the train function here, and the predict function here, which is the center of the entire program. Oh yeah, so before that also, there's something I want to mention for the loading function, which is written in this file. So in this file I wrote the loading function that is basically, because as you can see, going back a little bit, you can see that what I use is a binary picture. It's not a real picture, it's a binary picture, and you will need some tools to read it into the pixel data. That will give you a brief introduction here. So here you can see, so here with your root of your data, so this function can bring in the files here. So it will loop through every file, and it will just it will get the pixel information from the files. Yeah, so it reads in using this if stream, and so inside every picture, every data, so it will just create a buffer, so that it will put the pixel information in this buffer. So it read here, and then so here, because actually I can show you. So the data for this CFAR, the training base, it has 10 types. As you can see here, airplane, automobile, bird. So here I created a cat classifier, which means that, so if the label is 3, which is okay, so 0, 1, 2, 3. So if it's 3, then y the y of the training data will be 1, and if not, it'll be 0. All right, and the one important thing is that for the x part, you have to do a normalization for that, because you don't know the general pixel distribution for different kinds of items. So you need to normalize it, which is very important. So to reduce the bias in your data. And this for this part, another thing I want to mention is that for this normalization, you cannot just divide it by divide every number by 255, because there may the different features can have very different distribution on this pixel 0 to 255. So a clever way to do this is to have a mean for every every pixel in the data. As here you can see. So this mean here, instead of just put a round number of 255, you would just I did something that's like, okay, D is the dimension of every X training data, like every X. So the reason why this has a dimension of D is that I want the mean for every element of X instead of treating them all equal. This way, you will find later that this can greatly increase the accuracy of your program. Yeah. So this normalization is very important. So basically, that is you get in your data, and there's some normalization. That is what this function do. This is to load the training data, and also another function is to load the test data, which is the same thing, just loading the test data in. Okay, let's then go to the most important part, which is the functioning part with core functions using featuring cuBLAS. So yes, so most of the functions are just like as you can see, it's global core functions which are some real functioning part for the for these two functions. That's the train step and the predict probability. So for train step, actually, if you have some basic knowledge of machine learning or linear regression model, you can easily see what is done here. So basically, from your X, you will need a slope and a bias. So this will give you for the first result of Z. So and for Z, you will need some activation function to make it between 0 and 1. And the last step is just using some loss function to calculate the derivative, that is the changing rate of your W and B. And with that, you can just use the gradient descent to optimize your model. And yeah, that's basically the setup. It is very simple. So basically here it's just translate all this into different functions. So for example, here you need to initialize everything, initialize W and B as 0, and then this will be a core function, that is, this calculates the matrix multiplication of X and W here. So yeah, if you can easily get this. This is just a syntax of the cuBLAS SGE MV function. So what it does is to multiply the matrix based on their dimension. And yes, and after that you will add B, and for Z you will do a activation using the sigmoid, which is implemented here. And then so here you will apply the loss function here. I can go to here. Yeah, basically just you calculate the difference between your predicted value and the real value. So here, there's another important thing is that the meaning of this part is basically if the final result is, okay, say this is a cat. Basically, if it's a cat, then it's a 1, right? So if it's a 1 that is greater than 0.5, it will give a huge weight to the result. There's no why this is done is because the data distribution in your original training pictures can be very biased. Say, okay, there's only maybe one picture of cat and another like 9,000 of other things. Then actually it is just very hard for the model to learn anything useful about cats. So the thing is that actually you can change. This is just a hard coded number. You can change to anything that works the best. Basically, the point is you have to based on how your data is distributed, you must give some priority, for the type that you want the picture that want the model to learn about. So here I just use 9 to 1. So basically, if there's a cat picture, it will just give us a lot of weight for the model to see. Oh, okay, this picture is very important. This is the one that it wants to pick out of the 10 class. Yeah, and yeah, so after that, basically just you apply the DW and DB to optimize your model using a gradient descent. Yeah, and here this is where the learning rate comes to play. This is another very important parameter, as you know. So you also need to tune this to your requirement. And yeah, so after that it is simple. So actually here we don't, because for learning no, for linear regression model you don't really need the loss function. You only need to calculate the Boolean DB and use it to update your your function and update your parameters. That'll be enough. Yeah, so at last it just return the loss. Okay, this is the training step, and for prediction it's much simpler. Basically, just you use your model to calculate the prediction result, and just um, and then later after you get the result for the it will be stored in the alt p here, this parameter here, and after that, actually, if you go to the main function, after this, you will just do, yeah. So after here, you have this in your, this is your output, and you will just output, get it from the device, send it to the host, and do a little comparison on, to get the final accuracy. Yeah, simple as that. All right, and let me give you then a test like on what is going on. See, okay, so you first you build it, and here I've already done that, and with the executable file, you have some parameters here. So yeah, actually let me show you the parameters. The input parameters here is so they have some initial values if you don't want to input it. So that is the n is the how many data, how many training data you want to give your model, you want to feed in your model, and the next one is the iterations, like how many steps you want to train your model, and last one is the learning rate. You need to take some time to tune this into the best form. But here I'll just give you a brief example here. So I use 50,000 training data from the internet, and then I train 30,000 steps with a learning rate of 0.01. And as you can see, every 1,000 step it will output the loss, the accuracy, and the time it took. As you can see here, so the loss is decreasing, which is as expected, and the accuracy is slowly going on. Yes, so actually, if you just do some research on this data set, you can see that with just a linear model, this is very hard for the accuracy to increase, to very high levels. So just basically, if you get some number from say 65 to 75%, it'll be already pretty decent, which means that actually there shouldn't be something crazy or terribly wrong stuff in your code. So suppose this is going well, and because I run 30,000 steps, let's wait a little bit to get the last output to see how the test data set will go. Yeah. So as you can see, the rate of the decreasing of the loss is definitely decreasing. So from 78, 75, 74. So this is how to get pretty much reach a plateau of about 71%. Yeah, as you can see, after the training, the total accuracy of the test is 0.65, which is pretty much close to your training accuracy, which means that shouldn't be overfitting issue. So if you want, of course, you can run for longer steps to get a better total accuracy. But then maybe you will start to have some overfitting problems. But anyway, so this is already a pretty ideal and reasonable result to get, which means that the model is really learning something about the the pictures, about what a cat picture should be like out of all the other objects. Yeah, so actually I took quite a bit some time to figure out of course the code itself, and also the parameters, the correct parameters to have the best performance. Actually just the coding itself, it's quite simple. You just do some matrix multiplication. The calculation part is quite simple. The most part, the part that I spend the most time is on the tuning parameters, which is actually what you do if you are a machine learning engineer. Yeah, and I hope that this give you a basic idea of the how to use the cuBLAS library in building a simple linear regression model from scratch. And if you have any suggestions or comments, you can always contact me. I will put this entire thing on the GitHub. And yeah, thank you.